Hi everyone. So here we're going to see how to predict reactions and write equations for those reactions in both the balanced molecular form and then complete ionic form and then net ionic form. Let's start out with if you were given some words about the equation. Maybe you would say some calcium nitrate solution is poured into some sodium carbonate solution. All right, so write out the balanced molecular equation for that reaction and predict, so i.e. predict the products after writing out the reactants. All right, and so first you want to write out what the reactants are, their formulas. So first we have calcium nitrate. So calcium nitrate is an ionic compound. It's got calcium, a positive ion. You know it's got a +2 charge because it's in group 2A of the periodic table. And then nitrate, that's NO3 minus, a polyatomic ion on the polyatomic ions list found on our Google Doc lesson plans earlier. Calcium nitrate then must have 2 nitrates per 1 calcium. This is because you need to have just as many negative charges as positive charges. If calcium has a +2 charge, then you're going to need 2 -1 charges to balance out that. So you can know this just by doing crisscross. You're going to need 1 calcium and 2 nitrates, 1 calcium and 2 nitrates to have that formula. And then this is reacting with a solution of sodium carbonate. Sodium is in group 1A, so it's +1. And it's also with carbonate, which is CO3 2- on our polyatomic ions list. And there are 2 sodiums per carbonate because you need 2 Na+1s for a CO3 2-. All right, so there's sodium carbonate. Now, to predict this reaction, you can see that metals switch places with metals or with hydrogen. So here, calcium will switch places with sodium. This is a double replacement reaction. When you have a compound that has ions in both parts reacting with another compound that has ion in both parts. Calcium is going to switch places with sodium. But you're not just going to move that Na2 over here. You need to be careful to write a compound which has the simplest whole number ratios of ions. So you'll be bringing sodium ions to hang out with nitrate ions. So sodium is +1 charge and nitrate is -1 charge. So you need to have, crisscross, just one of each of those to balance out those charges. So sodium nitrate will just be NaNO3. And also you're having calcium, Ca2+, that's going to combine with carbonate, CO3 2-. The simplest whole number ratio of those together would be 1:1. Yeah, so like crisscross might show 2:2, but the simplest version is 1 calcium to 1 carbonate. Each one has 2- or 2+ charge, so they balance out their charge. This calcium carbonate will be a solid. You can predict this using the solubility chart provided in the Google Doc lesson plan. You'll see that when calcium ions are combined with carbonate ions, you have a compound that is insoluble, not able to dissolve in water, i.e. It will be solid, not dissolved in water, not aqueous. But the sodium nitrate here, this will be aqueous because on our solubility chart, you'll see when Na+ is with NO3-, you get something that's soluble, i.e. can dissolve in water, i.e. It will be aqueous, dissolved in water. Okay, so what we just wrote was the balanced molecular equation. So this kind of shows everything that's present during the reaction, but oftentimes this will show things that are more things than you need. To write the simplest version of the reaction, we'll first get to that simplest version, net ionic equation, by writing the complete ionic equation. So to do that, you take any compounds that are aqueous, ionic compounds or aqueous strong acids, and you'll break those up into ions. So, calcium nitrate was aqueous, it was a solution, and so what that really meant was in that solution, some calcium ions were floating around separately from the nitrate. So we had them separate, and that's represented by this plus sign. So just kind of actually looking at it, calcium ions are floating around, and so are nitrate ions. None of them are attached to each other. Instead, they're surrounded by water molecules. So that was aqueous. We broke up calcium nitrate into separate ions. Sodium carbonate is also aqueous. So break that up into separate Na pluses and a separate CO3 2 minus. Yeah, this is not Na2 plus. That is not a thing that exists. That would imply that Na is stuck next to another Na, and that never happens. Instead, we have separate sodium ions floating around, so you could show that with two Na pluses separate from plus a carbonate. So yeah, in solution there were two sodium ions floating around separately from each other and a carbonate. And then we could take a look at our products. Sodium nitrate was also aqueous. We know that because it was soluble. So there were two Na pluses, and there were also two nitrates, and they were all floating around separately in solution. And then finally, we had calcium carbonate. That was solid. That meant that the calcium and carbonate ions were stuck to each other. So calcium carbonate were stuck to each other as solid. We do not separate those ions from each other. They're not floating around separately. So we leave those as they are, just calcium carbonate solid. Okay, so that was the complete ionic equation. It showed everything in kind of in how it would look in solution. But you know, we have some things that are not changing here. They're just spectators. They're just watching. So they're spectator ions. Nitrate, there were two nitrates at the beginning and two nitrate ions at the end floating around. So nitrate really didn't change at all during this reaction. So it will not be in the net ionic equation, like the thing left over after we cancel things out that didn't change. Sodium ions also were floating around at the beginning and at the end. Those were also spectator ions. We'll cross those out as we get to the net ionic equation. So essentially all that happened was calcium ions were floating around in solution, carbonate ions were floating around in solution, and at the end they had stuck together to form a solid calcium carbonate. This is all represented in the net ionic equation, the simplest version. Calcium ions and carbonate ions were floating around, but at the end there was calcium carbonate stuck together as solid. Okay, and so kind of also looking at that here, calcium ions and carbonate ions were floating around, but at the end they turned into solid, while everything else didn't change. Everything else was floating around at the beginning and at the end. All right, now let's try a single replacement reaction. In this case, solid copper is added to a silver nitrate solution. So let's write out the balanced molecular equation. We had some solid copper and a solution, aqueous, of silver nitrate. Silver is +1 charge. It's always going to have a +1 charge if it has a charge. Silver is always +1 if it has a charge, and zinc is always +2 if it has a charge. But some other ions in the transition metal area, like copper, can be +1 or +2. Copper's +2 most commonly. Okay. Anyway, so we have these reacting together. Remember, metals switch places with metals or with hydrogen. So copper is going to react with it and switch places with silver. This is a single replacement reaction when an element reacts with a compound. And there's a switch. So now you're going to get copper hanging out near nitrate. Now copper pretty much always gets a +2 charge, and nitrate is NO3 -1. So to balance out the charges there, crisscross, there's going to be 2 nitrates per copper ion. And also, please take note that, yeah, you can look at the solubility chart to know that this will be aqueous. You know, you can see that anytime you have copper ions with nitrate ions, those together are soluble. soluble. But also, you can also memorize that anything with these ions is going to be soluble. Anything with sodium ions, potassium ions, lithium ions, nitrate ions, or ammonium ions will be soluble. Copper nitrate has nitrate in it, so that will be able to dissolve in water. And we have silver now alone. That will be the solid. Okay. Now, to get the complete ionic equation, we want to take anything that was aqueous and break it up into ions. So if we had 2 silver nitrates, then we would have 2 silver ions and 2 nitrate ions floating around separately in solution. And then we had aqueous copper nitrate, so that would mean we have a copper ion floating around and 2 nitrate ions floating around separately in solution. All right, and then what is not changing during this reaction? Just nitrate. But the other things did change. Copper originally had no charge, but now it has a +2 charge. Silver originally had a +1 charge, and now it has no charge. And not only was there a change in charges, but also in state. Silver was originally written like this, just showing a charge, so presumably it was aqueous, and now it's solid. So in our net ionic equation, we'll just have everything in the complete ionic except for the spectator ions. So overall, we can see copper got charge and silver lost its charge. This is a redox reaction. Copper was oxidized and silver was reduced. We'll learn more about that next time. And just to get a look what it would look like, originally silver nitrate ions were floating around solution and copper was solid, but later at the end, silver was the solid and copper and nitrate were floating around in solution.